Hey guys, lesson 12.1, task 3. We're at the end of task 3 because the video shut off and I'm not sure exactly when it cut off. But anyways, we're going to finish up the last question here on task 3. Alright, so it says, for an exponential function j with reference points 0, 1 and 2, 2, how can you write the rule for j so that its graph is a horizontal stretch or compression of the graph of f? Select the correct options to complete the statements. Alright, so for 0, 1, this is your ordered pair, x and y. The equation, alright, remember it's always y equals something to the x power, so x would be 0, would be in the power part, and 1 would be your y. So it says for j of 0 equals 1 for all real c, and that's true because anything to the 0 power equals 1. So for 2, 2, the equation is 2 equals 2 squared times c is true for anytime c is 1/2. So half of 2 is 1. 2 to the first power is 2. If we made c a 2, 2 times 2 is 4. And 2 to the 4th power is 16, not 2. So this one has to be 1/2 just to make this true. So again, half of 2 is 1. 2 to the 1st power is 2. So when c is 1/2, it makes that true. Therefore, the rule for j is j of x equals f of 1/2 equals 2 to the 1/2 times x. Remember, our base was 2. If you remember, we'll look up here above, and you know that that's where that came from. So in the very beginning, we had that f of x equals 2 to the x power. All right, that is all for task 2. Task 3. If you have any questions, please let me know. Lesson 12.1, task 4. When the graph of a parent exponential function f of x equals b to the x is transformed to obtain the graph of g of x equals a times b raised to the x power plus k, the reference points 0, 1, and 1b are mapped to the points 0, a plus k, and 1, ab plus k, respectively. So your reference points from the parent function 0, 1 are going to go to 0 and a plus k, and 1b is going to go to 1ab plus k, okay? So right here it's showing you that f of x is your parent function and g of x is this function. And to get those reference points, you're going to need these formulas, okay? So they're right here in the table. So it says the graph of a parent exponential function f is transformed into the graph of the exponential function g. Use the reference points to describe how the graph of f is transformed. All right, so these are your two reference points. This is 0, 1, okay? That's your first reference point. That comes from right here. And then your second reference point is 1b, and that's given right here. All right, so it says it's mapped to these points. So these points come from these equations here. So a plus k equals 7, and ab plus k equals 5. And then the 0, of course, and the 1, they're already there. So basically, you're looking for the new y values. All right, so it says the base of the parent function f is, okay, well, f, this is your b. This is 1b from definition above, so that'd be 1/2. And the rule for the function f is f of x equals 1/2 to the x power, because your base is, the base, and then raised to the exponent, which is x. 1/2 is just another way to write 0.5. How can you find the values of a and k in the reference points of g? Fill in the correct numbers to complete the statements. All right, for g, the table shows that a plus k equals All right, so right here, a plus k equals 7, because we're looking at function g, and we already know that the x value is 0, so the second, the y value, a plus k equals 7. All right, let's go ahead and let's write that down. So a plus k equals 7. All right, and we can fill that in here as well. And AB plus K, AB plus K equals, I believe that was 5. All right, yes. So right here, AB plus K equals 5. So this is going to be 5. All right, it says from part A, you know that B equals 1/2. So solve the system. Okay, systems. In the last unit, we solved systems of equations. So the first thing we're going to do is substitute 1/2 for B. So we're going to have A plus K equals 7. And then the second equation, B is 1/2. So we're going to have 1/2 times A. I just rearranged these using commutative property. Order can be switched around. And then when I set this up, I can see that I have a K in both of these, but they're both positive. So I want to subtract one equation from the other. Okay, so let's subtract this whole equation from above. So what's going to happen is it's going to be a plus, a minus, and a minus. I like to distribute that negative so that I don't forget to subtract across. Now I can combine my two equations and solve. So A minus 1/2, so 1 minus 1/2 is 1/2 A, and then K minus K cancels, and then 7 minus 5 is 2. All right, so half of A, to get rid of the fraction, I've got to multiply by the reciprocal, which is just 2. 2 over 1 is the same as 2. So A equals 2 times 2, or 4. So we know that A is going to be 4. And if A is 4, then we can find out what K is as well. So we know from right here that A plus K equals 7. And that came from one of the first formulas. So we're going to substitute 4 for A. And I'm going to subtract 4 from both sides. So now I know that K is 7 minus 4, or 3. So this one's going to be 3. And that helps me write a new equation here. All right, it says complete the statements. The graph of F is vertically stretched by a factor of... All right, so this one says G. So this one says F. So the function F is just f of x equals 1/2 to the x power. That's your parent function. We have that right here. F of x equals 1/2 to the x power. So it says the graph of F is vertically stretched by a factor of... It'd be stretched by a factor of 4, because A is what's going to stretch it. And is translated up, K moves it up or down, is translated up 3 units to obtain G. So the new equation is going to be G of x equals 4 times 1/2 to the x power plus 3. And all we did was take the values we found here for A and K and fill those in to this new function G. So G of x equals 4 times 1/2 to the x power plus 3. Now it says to transform the graph of a function h, the graph of G is reflected over x. All right, so what they want us to do is take the new function we just found. Okay, we just found this new function G, and they want us to translate it by reflecting it across the x-axis. So it says complete the corresponding reference points. All right, so I like to look at things. If I can get this to turn on. All right, if you click on y equals, you can graph this. So let's graph 4 times 0.5, or you can put in 1/2, it doesn't matter, raised to the x power. Make sure you bring this down, and I'm going to put plus 3. And then I'm going to hit graph because I want to see what this looks like. Okay, so it says to form the graph of a function h, the graph of g is reflected over the x. So here's the x. So we want to form a new function that's going to come and look like this right here. It's going to go down. It's just going to be a reflection across this x-axis. So our reference points, if our reference point's here, let's see what our reference point here is. So it's 0, 7. So our new reference point is going to be -7. And this point here is going to go from 1, 5 to 1, -5. So all we're doing is reflecting g across the x-axis. And again, I like to visually look at that, and using your calculator to find those reference points just makes it a little quicker and easier. All right, it says complete this statement to describe the transformation performed on the graph of f to result in the graph of h. All right, so remember f is the parent function. G was the transformation, and then h was when we reflected g across. So we're going all the way back to our parent function. So our parent function was 1/2. So the graph of f is a vertical stretch. Let me make sure I remember this correct. Our parent function is f of x equals 1/2 to the x power. Good. All right, so the graph of f is a vertical stretch by a factor of 4, and then it's translated up 3 units, and finally the graph is reflected over the x-axis. So the equation for h is going to be, remember the reflection makes this a -4, so all of these are negative. -4 times 1/2 raised to the x power, and then it will be -3 because remember it's upside down. When you reflect it across the x, it's upside down. Now you can always graph this to see if it makes sense. I'm a very visual person, so I like to see things work. So I can graph -4 times 0.5 raised to the x power, and then -3. And when I graph that, it should look like the same graph except reflected across the x-axis. And it does, so that verifies that this is the correct equation. And again, it gave us a green check mark, so it says it's correct, but I like to visually see how things work. All right, the graph of g of x and h of x with these parameters here. So you've got g of x equals a times b to the x plus k, and then h of x equals c times b to the x plus l. So it says with these parameters determine, label the y-intercepts and the isotopes. All right, so it says the value of the parameter do not affect the domain of the function. That is true. The domain is all real numbers. All right, so it says A, C, K, and L, A, C, K, and L all affect the range. All right, the range is your y values. It's going to move it up and down. So A does not affect that, but your C, K, and L could affect that. A, C, K, and L all affect the end behavior. Again, A doesn't affect your end behavior, but C, K, and L could affect the end behavior as well. All right, that's all for task 4. If you have any questions, please let me know.